Alright, in this video we're going to take a look at alpha and beta decay. We're going to talk about gamma radiation. We're going to look at what exactly is going on and how to solve problems with each of these. First of all, the symbols for alpha and beta decay. There's two different ones for alpha. I prefer the helium nucleus, which is a 4 mass and atomic number of 2. Alternatively, you could actually use the alpha symbol. That would be the same. It has a mass of 4. 2 protons and 2 neutrons make up an alpha particle, so it's 4 different things. And it has an overall charge of positive 2. As you can see, it has an atomic number of 2 because there's 2 protons there. The beta particle, the symbol I prefer is the electron, the E, with a 0 over a -1 charge. It's a -1 because an electron is sort of the opposite of a proton in charge. Alternatively, you can use the beta symbol, and its charge is a -1. Okay. Gamma radiation, gamma rays, or the Greek letter gamma, 0 mass, 0 charge. You can see that they are massless, it's pure energy, and again, no charge with those, so they don't affect the actual product of a nuclear reaction. There we go. Okay, so here's the general form for alpha decay. What you see is whenever you have an unstable atom, something that is really bulky, that is not able to stay together, it will spontaneously undergo this process called alpha decay. And what it does is the alpha particle is emitted from the nucleus of this unstable atom. So here, radium-226 is an unstable radioisotope. So the alpha particle gets ejected out and it loses that mass. So whereas radium had 226 particles in its nucleus, well, it just lost 4 of them as a helium nucleus, so 4 of them are gone. So now there's only 222 things remaining. And 2 of those things were lost as the atomic number. So it doesn't have 88 protons anymore, it now has 86. So the resultant isotope would be radon-222. Because the atomic number changed, the element has to change also. With beta decay, we see that beta decay is simply the process by which one of the neutrons inside of here, so we get a neutron that will change and will actually become a proton. Well, because the neutron turns into a proton, that's not any new matter or there's new mass being gained. It was already there. It just kind of switched teams. It was on team neutron, now it's on team proton. So the mass remains the same, but the atomic number goes up because we gained 1 charge. That neutron's now kind of turned on, and it is now a positive charge. That's why mass stays the same, atomic number goes up, and the actual beta particle is this fast-moving electron, and electrons do have a negative charge. So let's take a look at working some of these problems now. Okay. The first one right here, we're presented with gold-211, and we see that a beta particle is emitted, and we need to determine what isotope was formed. Well, what we can remember is that with beta decay, it's 1 to the right. Meaning that if iridium underwent beta decay, you'd go 1 to the right to find platinum. If platinum undergoes beta decay, you go 1 to the right to find gold. Okay. With alpha decay, it's 2 to the left. Okay. What that means is if plutonium undergoes alpha decay, you'd go to the left and get uranium. If gold underwent alpha decay, you'd move 2 to the left to find iridium. Okay. So in this case, we see gold-211. We know that it's beta decay, so that we are going to go 1 to the right. So I know that I'm going to have mercury as my answer. Now we have to determine the mass and get the atomic number. Well, you can think of this as an equation also. This arrow is like an equal sign. So what I'm saying is 211 for the mass has to equal 0 from the mass of the electron plus the mass of whatever the isotope is going to give me. So, well, what plus 0 equals 211? 211 does. So I know that the mass of this is going to be 211. Now I'm taking a look at the atomic number. So I'm saying that 79, I've got an arrow, so that's the equal sign down here also. 79 equals -1 plus Z. Well, what plus -1 will give me 79? Well, the answer is 80. 80 plus a -1 is 80 minus 1 is 79. So I know that my atomic number had to be 80. So like we predicted based upon the rule that beta decay is 1 to the right, I find out that the result of this is mercury 211. Okay. The second problem is an alpha decay. We see that we have neptunium 175. It's going to emit an alpha particle and become a new element. Well, alpha decay tells us it's going to be 2 to the left, so we started with neptunium, so it's going to be 1, 2. I know that's where we're going to end. You can look at it like a basic algebra problem again. I see that 175 equals 4 plus A. Well, 4 plus what equals 175? Well, 171 plus 4 equals 175. And now for the atomic number, I'm saying 93 equals 2 plus Z. Okay, well, 2 plus what equals 93? 2 plus 91 will equal 93. And that's how I was able to arrive at the correct mass and atomic number and find the right element for this one. Again, this time we have beta decay, so we are ending up at polonium this time. So rather than figuring out what we were ending with like the first two problems, we want to know what we started with. Okay. So looks like they actually forgot the arrow in this problem, so we'll go ahead and just put that in there. So what plus this gives us polonium 213? Alright, no problem. I know that something equals 0 plus 213. Okay, well, what? I add those together, I get 213 for my mass. I'm looking at the bottom. Okay, Z equals -1 plus, well, they didn't give us the atomic number for polonium. Well, no problem. You can always look at the periodic table. This will only ever be 84 for polonium. Every element is unique based upon the number of protons that it has in it. So I'm faced with Z equals -1 plus 84. Well, if I add -1 to 84, I end up with 83. So, like we predicted, with beta decay, I'm sorry, yep, we'll go the other way. We started with this. You would have gone 1 to the right. So, if I was at bismuth, I would have ended up at polonium, and we see that's what we did start with, bismuth 213. Now we have a couple of word problems. The biggest challenge in solving word problems is determining where to start and where you're going to finish. Well, this one says uranium-238 undergoes an alpha decay. So that suggests to us that we are starting with uranium-238 because it's saying that, hey, uranium-238 is having this happen to it. So we'd start off by writing out our isotope of uranium-238. And it undergoes an alpha decay. An alpha particle is just a helium nucleus. It doesn't matter if I write the alpha particle before or after the other isotope. Commutative property of math says it doesn't matter where I write things if there's a plus sign in between. Now we have to determine what we are going to get. Oh, by the way, we get 2 gamma rays. So you can just add those in there. A gamma ray doesn't affect anything. It's just energy that comes off. Okay. So we can ignore these because they're just zeros. What I'm asking at this point is, I know that I'm going to add 4 to whatever this is in the mass to get 238. So it's going to be what plus 4 will give me 238. Well, 234 plus 4 gives me 238. Same with the mass. I'm saying to myself, what plus 2 equals 92? 90 plus 2 equals 92. So I just need to determine what element this is, and I see that 90 is thorium. So this is the alpha decay of uranium-238. And the last one, neon-22 nucleus is formed. Okay, using those context clues. It says this is formed. So that doesn't sound like that's what we start with. It sounds like we ended up with a neon nucleus. So already I know that something is happening, and I know that I'm going to get neon-22 out of this. Again, the 22 refers to the mass, which is written up top. Neon has an atomic number of 10. So it was a beta decay. So we know that this was beta. Okay. So all I did is wrote what was told to me. It said neon-22 is going to be formed, and it was a beta decay. So now it's just a matter of, well, what radioisotope did we start with? Okay. These are math problems. You can think of the arrow as an equal sign. So I know that it's going to be 22 plus 0. So already I can tell that my mass for whatever this radioisotope is going to be 22. And I've got 10 plus negative 1. Well, what's 10 plus negative 1? That's 9. And the element was fluorine. You can check your work. We know it was beta decay. Beta decay goes 1 to the right. So if we start with fluorine 22, we should end up 1 to the right with neon, and we did.